So I need some way of doing resource management of like these GPU resources, so buffers and textures, and I have no idea how to do that. So today we will think how one should actually do these things and what is the important thing. So in DirectX 12 we have heaps, and then we have descriptor heaps. So the heap is just a, it's a memory thing where you can then allocate your resources. So let's say that here in the heap we would have a texture. Yeah, and then you would have some buffer here. And so on. And then in the descriptor heap, you would have basically the descriptors of these resources. So in reality, I think it's just quite a simple pointer to the actual resource in the heap, in the descriptor heap. So they just point to the start of the resource, and then the GPU can go and read them. And you don't actually really need to use descriptor heaps for certain things. You can just pass the raw virtual address into the shader and just use it that way. So that's quite nice. Anyway, for example, heap and the descriptor heaps, they're not really managed by the GPU anymore or the drivers. So it's kind of, developers are responsible to handle all the memory and what's not. So every time when we place a resource to the heap, what we need to do is that we need to give it an offset, and the offset needs to be aligned most of the time to 64K. And there's the simplest way to handle heap is just to use it as a linear allocator. So it's just always increment the offset by the size of the resource aligned to 64K and so on. But then do we want to evict things from the heap? Maybe. So we need something more complex. So we probably need some sort of an allocator that can manage the heap. Yeah. And then we also need a way to manage the descriptor heap. So, we can evict things from there and put them back here and so on. So kind of need to figure out how to do that. Yeah. So I have implemented a very simple heap allocator that works by like I don't know what to call them, as blocks and like their ranges. So say we have a heap that has like every block here or rectangle slot would be 64K in size, and then we would have a list of free ranges, and then every time when we allocate something we would then split the allocation part off from that list. So this would get allocated, and then this would be the next one, and then you would go and allocate something there and so on. And then when you free, you would create new entries, and if you free from somewhere where you can then expand it, then you would expand it every direction and so on. But yeah, this would quite nicely, it should kind of solve the heap issue where we need to keep track of this offset number, as this would then the allocation would give you the offset where it should be placed and so on. And we can hide that kind of information behind the allocator, so the user can just call allocate texture and give the resource descriptor and so on to it. But then how do we handle the descriptor heap? We probably can do something similar that we do here with the heaps, but I'm not sure if that makes sense. Like, because how I think of this, that is, we would have like a, well, not material, but you would have like a material that would have like texture ID, and then it would have something else, and these IDs would then point to the descriptor heap. So you know, you could do like bindless thing where you don't bind any texture individually to the pipeline, but you would use this kind of texture ID pointer to figure out from where in the descriptor heap do you need to read in the shader and so on. But then the question is, how do we evict things from there? Like when we free something, like let's say we free a material and the material had its texture whatnot allocated to it, so we then need to kind of go and get rid of this thing. Of course, it points to the texture, and also kind of go and remove the texture maybe. If nothing is pointing to it, I don't know. I need to think about it. But yeah, so maybe we could use some sort of like a bit mask. So each descriptor heap, let's say, it would get like 64 items. We can later increment it, but let's say by default it would have 64 items, and it would have like 0, and then there would be like 64th block. So we could just use the bit mask to tell what is here free and what's not, because the increment size for each descriptor would be always the same, given that you need to tell the descriptor heap when you create it what is the type of descriptor that it contains, so like shader resource views or constant buffer views or unordered access views or something like that. But anyway, those are all the same. They will have the same size, the increment size. And then if you want render targets, they need to go their own descriptor heap and so on. So in theory, we could just do this bit masking, and then it would tell which parts of this is free, where we can insert things. But of course, then we will run into a problem where if we remove something from here, but the ID of a material would, for example, point to that removed item, what would that actually mean? We would probably use the old texture that this is pointing to, but even if that's removed from the actual heap, then I have no idea what would happen. And how you would prevent that. Well, to prevent it, you would probably like, I don't know, would you just have some reference counters and so on, and that would then tell like, okay, once there is no materials alive that are pointing to reserved slot, then we can evict everything, that resource from the heap. But then that's like not the nicest way of doing it, but maybe this, I don't know, at least it should be quite simple to do it that way. But I'm not sure, do you even need that kind of like reference counting or anything like that? Like, you know, I'm mainly using this, so I can be probably quite confident that, you know, if I reserve something, I will know that, okay, I need to also delete it or release it from the heap. But yeah, I don't know, just some madman's ramblings for now until I come up with a better solution for this. Yeah, anyway, but that's the next step. And then from yesterday's demo, we didn't have any textures. Now we have a texture. This is very simple demo. Of course, it doesn't have the whole model load it, but you know, just proof of concept that I can render actual textures with the current implementation of the backend and so on. But yeah, anyway, hopefully in the next video I will have some sort of nice way of handling resources and keeping track of them. Anyway.